Yes, I'm audible. Work.
Yes, sir.
Today, have you prepared all analytical chemistry?
Yes, sir. You can, sir, ask from physical inorganic also. Sir, analytical I have seen.
Okay, complete enough. Yeah, first of all, basic introduce yourself, and will we discuss.
Sir, I am Orku Manna from West Bengal, East Midnapur. Sir, I have done my schooling from our native school, and after that, I have done my B.Sc from Belur Ramakrishna Mission Vidyamandir, and then my M.Sc from IIT Bombay. And uh, my hobby is to motivate the local students and to specific their career growth in which field they should go. And also, my hobby is to going to gym. Sir, I have mentioned these 2 points in the hobby section of the tab, that to motivate local student and local student and
Yes, no problem.
going.
Yes, good.
Yes.
No problem. Hobby. Yes, next move on analytical section. Yes. What the main application of
Yes, sir.
analytical chemistry?
Sir, from analytical chemistry, we can know about the minerals, forces, and what is the composition of any compound is there, or main application is of that in the food industry, in the pharmaceuticals, and also for analysis, any forensic report, if there is any cation or anion is present or not. Main purpose of analytical chemistry is to detect which material is present in it. So it may be organic compound or it also may be inorganic compound. So main purpose of analytical chemistry is to analysis which compound is there.
Yes, good. What the difference between analytical chemistry and chemical analysis?
Sir, in chemical analysis, it's specific actually. Specifically, we analysis a sample, what is it composed of. But in analytical chemistry, actually, the whole thing actually cover. Analytical chemistry is a huge portion, and chemical analysis is a short portion of under the analytical chemistry.
Yes. What is instrumentation? What is instrumentation? What the role of instrumentation in analytical chemistry?
Sir, by instrumentation, we can specifically know about the characteristic of a chemical by that is UV or IR or NMR. By using or fluorescence spectroscopy, we can specifically denote that this compound is there, and its quantitative and qualitative both the measurement can also be possible from that, from the use of analytical chemistry, from the use of instrumentation, or there is ICP-MS or other things. So from ICP-MS also we can quantitative and qualitative analysis possible from flame spectroscopy.
Yes. What is separation technique and how many type of separation technique in analytical chemistry? Describe one by one.
Sir, separation techniques means column chromatography. There is, if we say that is partition chromatography, and the absorption chromatography, and there is ion exchange chromatography, size exclusion chromatography. These are there, and specifically there is gas chromatography also there to specific analysis, and HPLC is under the absorption chromatography. So, sir, will I describe about all these things? Hello, sir.
Yes. Separation
Sir,
technique.
in the absorption,
Yes. Adsorption.
sir, in the absorption, sir, separation technique means you are telling about only not only the chromatography, but also there is
All. Yes. All. Yes. Adsorption, chromatography. So many crystallization, electrophoresis, extraction, evaporation, precipitation, filtration, simple
yes,
distillation.
sir. Yes, sir.
So
Distillation, by distillation also we can done.
yes.
Yes.
This one only basic. Yes. Next, move on. Analytical chemistry is a analytical chemistry two part. Qualitative and quantitative analysis. What's the difference of these one?
Sir, in qualitative analysis, we can detect the which compound is there, and in quantitative analysis, we can detect how what is the amount it is present, in which amount it is present. The amount of any compound can be known by quantitative analysis.
Yes. What is volumetric analysis?
Sir, volumetric analysis. Uh, sir, sir, give a example, sir. Of sir, I that actually don't recall it. Volumetric analysis. Sir, please give a example.
Volumetric analysis is a quantitative analysis. Do you know?
Yes, sir. Quantitative analysis. Oh, okay, okay, sir. Volumetric analysis. Titration is one of the volumetric analysis. I just forgotten what is the volumetric. Sir. So by titration, we can any type of titration is under the volumetric analysis. So by volumetric analysis, we can measure the actually if we know the what amount of molarity is in solution, and what is the volume of the solution, then we can easily detect of by a known compound of solution a unknown compound of solution in which amount it is present, if we know there some chemical characteristic or other thing. So by using titration, different various type of titration, we can volumetrically analysis the compounds. So mainly by the titration. The titration is the volumetric analysis. Yeah.
Yes. What is solution and how many types of solution?
Solution is the solution. Solution is mainly it may be liquid solution, solid solution, or gaseous solution. So solution is actually we are mixing two different compound in a area. So maybe solid liquid solution, or solid solution, solid liquid solution, or liquid gaseous solution. Like liquid solution, if we mixture any two liquid of same viscosity, they will be soluble, and if we soluble any type of salt in water, they will be soluble. And if we also it may be also if two metal also can be soluble. So if we heat two metal, and they also can be soluble. heat to metal, and just like the alloy air forms in that way by using metal solution, metal solution.
Yes, solution is two types, ideal and non-ideal. What the difference?
Okay, ideal.
Ideal solution is follow the Rolt law.
Yes, sir. Ideal solution follows the route law, and non-ideal solution follows don't follow the route law. Route law suggests that and the Dale age of the ideal solution is 0, but Dale age of the non-ideal solution is not equal to 0, and the volume change during if we mix two solution, so the change in the volume is also not equal to is 0 in case of ideal solution, but there is volume changes in case of non-ideal solution. So this is basically because of the vapor pressure created by the solid molecule.
Yes, what the difference between solution is molarity and molality?
Sir, molarity means mole per liter. In every 1 liters, how many moles of any solute is present. But in molality, it indicates that how in the mole per kg. Kg means that kg of this much of kg of solute, how many moles of solution, how many mole of solute is there. Solute is there. So it determines to weight, molecular weight, but there is in molarity, in case of molarity, there is mole per liter, but it is in mole per kg. So in the means how many kg one means in a 1 kg, how many moles of solute is present in case of molarity.
What is normality?
In normality, how many gram equivalent of any molecule is present in 1 liter of solid. So gram equivalent means the like H2 for H2SO4, it will be gram equivalent will be its molecular weight divided by 2. Like calcium hydroxide, it gram equivalent will be molecular weight by 2. Like anyways, it molecular weight by 1. So it will be the gram equivalent weight by the 1 liter of the solid.
What is titration? What is titration? Describe.
Sir, in titration, actually, titration is a quantitative measurement. So here we want to know in a solution how much amount of any composition is present. So for this, we apply external solution to react with it, so that other external solution we put from Pure, so that it will react, and a definite indicator will must be present in case of titration. So this indicator indicate that where will be the end point, and in which case the reaction, both the neutralization or oxidometric reductometric reaction are completed, in which case. So indicator represents that there both the reaction will be ended. So by using proper indicator, we can use this type of means titration reaction.
Next one, what is acid-base titration?
Sir, in the acid-base titration, we use in the burette either acid or base, and we know the amount of what is the molarity of the compound we are applying from the burette. So by this, we can measure that, and we use a proper indicator like phenolphthalein or methyl orange indicator. And by using this indicator, we know the end point where the reaction of acid-base titration are completed. From this means acid and base react in this in the solution mixture. So from there we can determine either the unknown concentration of acid or base. So we basically use acid-base titration to know the what amount of acid or what is the molarity of acid or base is present in there.
What is titration of more salt?
Sir, titration of
More salt, more salt,
more salt. Sir.
Yes.
Sir, titration of more salt mainly done by the oxidometric reductometric reaction. So more salt there is Fe2 plus is present. So Fe2 plus Fe2 plus to Fe3 plus reaction is happens. So it is actually acts as a reducing agent. So externally we use oxidizing agent like MnO4 minus or Cr2O72 minus. Externally we use, and we can determine what is the amount of Fe2 plus is present in the. Actually, more salt is a dibasic salt of ammonium sulfate and FeSO4. So by knowing the interview, by knowing the exact amount of by knowing exact amount of Fe2 plus, we can determine the what is the mole of more salt is present. So here actually we externally use chromium Cr2O72 minus or manganate or other oxidizing agents to determine the oxidometric reductometric titration.
Yes. What the role of more salt in titration? What the main purpose?
Sir, what are the?
What
Sir,
the
please
main
repeat.
purpose of more salt in titration? And what the role of
Okay.
more salt in titration?
Sir, by more salt actually we can analyze the power of the Cr2O72 minus and manganate, this oxidizing power, their oxidizing power we can calculate. That is, what is their normality or molarity is present. Normality means actually their oxidizing power or means E0 value we can determine. E0 value we can determine of any unknown means oxidizing.
Yes. यस टाइट्रेशन का जो एसिड बेस टाइट्रेशन है उसकी ग्राफ को हम कैसे आइडेंटिफाई करेंगे, किस तरह से एक्सप्लेन कर सकते हैं इफ स्ट्रॉन्ग एसिड और स्ट्रॉन्ग बेस है?
Yes, in strong acid and strong base. So if we use base, so if a container there is acid and we are pouring the base, so firstly firstly there will be the graph will be the under of the curve because there is acid. So if there is acid, the pH value will be the a strong acid pH value will be the near about 1. So from 1, it will increase when we are giving the base, and at the end point, it will increase exponentially. So it will increase exponentially to a strong peak, and then it will be flat again after the end point when we are using the base. Then also it will increase. So firstly will be the neutralization reaction. Firstly, the pH value is for the concentration of H plus ion of the acid, and then when we are neutralizing by OH minus, so acid concentration H plus concentration decreases. So firstly peak will be increased, and then when the total H plus and OH minus concentration is 0, the exponential curve will be shown, that is the flat straight curve, and after that OH minus concentration increases, so the curve will be flat, means almost flat. Means flat, not flat, it will increase again also. Means pH
Yes,
up to
increasing
12 or
only.
13. Yes,
Other one is weak, if using weak acid and strong base, so what will the graph and what is
sir.
the formula?
This, what will be the?
फॉर्मूला कैसे यूज करेंगे यूज इन पीएच
Okay,
फॉर्मूला
sir. Henderson equation, we can use Henderson equation
यस
in case of it. And pH value will be the start from slide upper, that is for from 4, and then uh, the straight curve, that is in the end point, that the straight curve will be the something narrow value, like it will be not like acid base, strong acid and strong base curve. So the end point, there will be the curve will be the something like small. So actually, sir, if it is in written in uh, note, so it will be easy to explain by not telling you.
नहीं है व्हाइट पेज है आपके पास
हाँ सर, व्हाइट पेज।
एक्सप्लेन कीजिए एक्सप्लेन ऑन व्हाइट पेपर
Means it is normal, sir. That is the for the strong acid. Strong acid is, I want to say that this car will be the like that, but in weak acid it will be something like flat, something like small increase, means so not so many upmost. So it will be the start from here, that is pH from 4 or 5, and it will be end like 11, 12 in this way. So it is strong acid and it is strong weak acid, and strong base like in which way. And here we are using Henderson equation in this case, in the position of that.
Other one is weak acid and strong acid weak base and strong acid
Sir,
weak base
please
and
repeat.
strong acid
Weak base and strong acid.
yes
So here we have to use strong acid in case of burette. We have to use drop by drop HCl on weak acid like ammonia or ammonium hydroxide. So car will be like in this way. So sir, car will be like in this way. So here we are applying HCl. So firstly there was base like ammonium hydroxide or other thing. So pH value is high, and when we are using HCl, pH is decreasing. So here in case of burette, we have to use HCl. So we have to spend a drop by drop HCl from farm.
yes good what the formula of pH weak
Sir,
base
what is the formula of
pH how to
what?
determine the pH value
P-
formula
pH equal to minus log of K, pK.
yes Next one, weak acid and weak base. What the formula and how to describe on graph?
Hmm. Sir, in case of weak acid and weak base, there are different regions. Firstly, in this region, hello, sir.
Yes, yes.
Firstly, in this region, where is a increase of that. Here actually increase due to the dissociation of we are using weak acid like CH3COOH and weak base like ammonium hydroxide. So when we are using CH3COO, first drop of ammonium hydroxide is there, then it will be the converted to CH3COONH plus, and there will be the increase of its dissociation. So pH will be the increase firstly, and then in this portion we are using Henderson equation to denote that. So here actually we use Henderson equation for in case of the acid, Henderson equation on acid. So by this we are using this graph, and then also then for that portion we after the neutralization reaction, if we use it in Henderson equation also, we will get this point also, that the end point of this reaction. And after that, for this portion we will have to use Henderson equation in case of base. So here base are also as weak base. So for weak base also we have to use Henderson equation in this case also. So there are actually four different part: one part, two part, three part, and four. Four different region and four different thing happens in this four.
Yes. Yes, good. Next move on. Next topic is chromatography. What the main application of chromatography? How many types of chromatography?
So there are various type of chromatography like absorption chromatography, partition chromatography, and ion exchange chromatography, size exclusion chromatography. And the main purpose of chromatography uh, is to separate two compounds in a mixture. So if there is any unknown reaction we are doing, so we are getting two compounds. So how we can separate the two compounds separately by using chromatography. So main purpose of chromatography is to detect different compound separately, and also to separately collect the two or more different compounds.
What is adjacent chromatography? Adjacent chromatography. What the uses?
Sir, by using absorption chromatography, we also use is also same, that we are separating two different compound, two or more different compound, and we are getting them in the pure form. So actually, absorption chromatography depend on its polarity and non-polarity. So in absorption chromatography, we use a polar stationary state and a non-polar mobile field. So by using by so if there is a difference in the polarity, little bit difference in the polarity, so of the two or the more different compounds. So on the basis of polarity, they will be separate. So actually, main purpose of absorption chromatography is also separation of the compounds in a mixture.
Yes, adjacent chromatography is column method and gas solid chromatography. What is the difference between column method
Sir,
and gas solid chromatography?
okay, sir. In column chromatography, we are in both of the case, the stationary phase is solid. But in case of column chromatography, the mobile phase is liquid. But in case of gas chromatography, the mobile phase is gas like helium or nitrogen gas. In case of gas chromatography, we the mobile phase is helium or nitrogen gas, or maybe use hydrogen gas. So there is difference in mobile phase actually, and also there are structural difference. So gas chromatography is more complex, and we can use detect a very small amount of detect and separate very small amount of sample also in the gas chromatography.
Yes. Next one is partition chromatography. What is partition chromatography and how many types of partition chromatography?
So partition chromatography means mainly uh, the paper chromatography is under actually partition chromatography.
Yes, right.
So they are actually mobile phase and the stationary phase both are liquid. Actually, in the case of paper chromatography, it is actually liquid which is bind in the cellulose. So the liquid which is bind in the cellulose is used as the stationary phase. So
Yes, partition chromatography four type: liquid partition, paper chromatography, thin layer chromatography, or extraction chromatography.
sir, I have not heard. Sir,
Liquid,
please tell again.
liquid partition chromatography, paper chromatography, thin layer chromatography, extraction chromatography.
Okay, sir.
These are the part of
So,
partition.
sir, what are the?
Part from partition chromatography. These are the part from partition
Okay,
chromatography.
okay, okay, सर सर एक्चुअली साउंड प्रॉब्लम हो रहा है
Okay, okay, no
मेरा
problem.
इसमें.
Okay, okay.
Okay.
Next one, ion exchange chromatography. What is ion exchange chromatography?
Sir, in case of ion exchange chromatography, if we are interested in separation of cations, so we are using stationary phase, which are actually negative charge. So it can bind with cations, so that and on the ability of binding of cation or anion, it actually it separate the cations or anions. So if we are interested to separate cations, so we are using uh, stationary phase like R2 minus or like that. Means long polymer change with a negative ion in the end. So this negative ion will bind more stably the cation which is strongly bind, like there is M2 plus or M plus. We are separating M2 plus and M plus, so it will strongly bind with M2 plus, and so M2 plus will come later and M plus will come faster. So we can separate M plus and M2 plus from this ion exchange chromatography. And also, if we are interested to separate different type of anions, so we will use R plus, means ammonium plus, means like polymer change, and लास्ट में अमोनियम प्लस आयन होगा, तो अमोनियम आयन विल बाइंड द एनायन एंड strongly bind with which anion is less strongly bind, it will come fast, and which anion is more strongly bind, it will come later. So ion exchange chromatography also in the two types it may be. So cation exchanger and anion exchanger.
Yes. Ion exchange chromatography type is a cation exchange, anion exchange, inorganic exchanger, liquid exchanger, ion chromatography. Yes. Next one is exclusion chromatography. What is exclusion chromatography and how many types? And electrochromatography, how many types?
Sir, exclusion chromatography means size exclusion chromatography, and in size exclusion chromatography there is pore size is different. So if the particle size, it actually analyze the sample by using it particle size. If particle size is small, it will take more time to pass, because it will go through the particles of the stationary phase, so it will take more time to pass. And if the particle size is large, it will come faster. So by using this property, uh, uh, we use actually this property in the case of size exclusion chromatography to detect the two ions and to separate them. So here actually main issue is size. So on the basis of size, we actually separate two or more.
Yes. Gel emissions and ionic exclusion and molecular seed. Next one, electro.
Sir, electrochromatography, I think uh, by the cathode and anode, there are cathode and anode, and the anion will go to the cathode, and cation will go to the anode. And by this, actually, we use this technique for in the case of amino acid separation. So amino acid are maybe positive and negative. So by using this technique, we can separate amino acid by using different type of pH, maintaining different type of pH. We can separate different type of amino acid by electrochromatography.
Yes. Good. What the beneficial of chromatography in our society? Any point? 4, 5. And drawback of
Sir,
chromatography.
in case of food industry, we are using it heavily. So in the food industry, we can analyze the what the samples are there, and if there is any impurities present or not. In case of forensic, we can also use HPLC GC technique. So if we detect something, and to detect that what is the compound is present there. So by using this, we can also use this. And also in case of uh, I think in case of food industry, and also in the beverage case, like any type of liquid is there. So if there is any type of mixture is present or not, we can use this. Sir, time remaining, sir, it is showing that one. Sir, will I join again?
Yes, one minute. Next day. No problem. 1 minute is left. Next day we will discuss left part of analytical and inorganic organic. Yes.
Sir, I actually seen total part today.
Today.
Sir, have you time, sir? Sir,
No,
then can I
other
join?
candidate. Yes, other candidate time.
Okay,
Block into 6
okay, sir.
p.m. in other candidate.
Okay, sir.
Yes, carry on. Drawback of chromatography.
Sir, drawback of chromatography. In case of drawback of chromatography, uh, it may be expensive, and it cannot be used everywhere. And detection limit. Every chromatography technique have a detection limit. So like uh, so they cannot be separate more prominently. And in case of new analyte that we don't know about its characteristics, so in that case it may takes time to characteristic it, and so chromatography technique cannot be used in case of a new sample. So if it can be used known sample for a known sample very prominently that this compound is there. But if it is an unknown compound, so then we cannot say that yes, this compound is there. So this technique have that drawback. So uh, like instrumentation technique have more feasibility like in MRIR. So by using this technique, we can easily detect any compound. So but not through chromatography, we cannot sure that this compound is there.
Yes, today's good work.